Hello again, still week 1. We're in section 1.2 and we're trying to check that x equal to c1 sine t plus c2 cosine t plus e to the t is a solution to a certain equation, x double prime plus x is equal to e to the t. And then we're trying to solve an initial value problem with these parameters. So let's first check the derivatives. And so if I look at x prime, here prime of course denotes derivative with respect to t. The derivative of sine is cosine, so this is c1 cosine t. The derivative of cosine is minus sine, so this is minus c2 sine t. And the exponential is, of course, our favorite function for differentiation because its derivative doesn't change anything. And so the second derivative is minus c1 sine t minus c2 cosine t and e to the t. And so our equation is x double prime plus x on the left-hand side, and that is equal to, let's see, we're adding c1 sine t with minus c1 sine t, so that gives 0. And then we're adding c2 cosine t with minus c2 cosine t, so that also gives 0. And then we have e to the t plus e to the t, so that's 2 e to the t, and that is 2 e to the t, which is what we were supposed to get. So this is a solution. It has two parameters. This is a second order equation, and so we've kind of come to expect that we get, for every integration, we get a parameter. So here we're integrating twice, anti-differentiating twice. We should get two constants. That may be a little far-fetched for now, but so far that's been our experience. Let's look at the initial conditions that this satisfies, just for fun. If I look at x of 0, then that sine of 0 is 0, so that gives c2 times cosine of 0, which is 1, and e to the 0 is 1. The derivative here was cosine, so this becomes c1 times cosine of 0, which is 1, and then the derivative of cosine is minus sine, so that gives 0, and the derivative of e to the t is e to the t, and so at 1, that's 1. So those are the initial conditions, and you can see that we can match. We can choose c1 and c2 to match any value of x at 0 that we want, and every value of x prime at 0 that we want. And of course, the second derivative is determined by the first two.